Okay, so these are the answers to the vectors questions from Past Paper Penguin. These are the more basic vectors questions. If you want the more challenging questions, they're in a different document. So let's start with this one. We want A to B as a column vector. So the top number means how many right, the bottom one means how many up. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 left. So the top number is minus 10. And then 1, 2, 3 up, so that bottom number is 3. So minus 10, 3. We could also use the numbers on the axes to help us figure those out. In this next question, we're asked to draw and label a vector 2a. Well, the vector a is 1 across, 2 up. So the vector 2a is just double that. So that's 2 across, 4 up. Okay. If you like, you can also figure that out by doing 2 times the vector, and sure enough you can see that that gives us 2, 4. Okay, let's just label that. I should really put an arrow on there, and there we go, 2a. The exact positioning of that vector doesn't matter. I could have put it down here, you know, over to the right here. It doesn't matter as long as it goes 2 across, 4 up. Okay, this next one, I think we will calculate it first. It wants us to do a minus b, so let's do that first. A is 1, 2, and then subtract b, which is minus 3, 5. Okay, we've got 1 minus minus 3, so that's 1 plus 3, which is 4, and then 2 minus 5, which is minus 3. So let's now draw that vector. So we want 4 to the right, 3 down. Again, it doesn't really matter where I start from. 1, 2, 3, 4 right, 1, 2, 3 down. I'm pretty sure they're going to want us to put the arrow on it as well, so let's do that. And there we go, there's our vector a minus b. Okay, so now we're asked to find u minus 2v. Let's write those two things out first of all. So u is 3 minus 2, and then minus 2 times minus 12, 5. Okay, I'm going to leave the subtract here, and I'm just going to do 2 times each of these. So 2 times minus 12 is minus 24, 2 times 5 is 10, and then I'm going to do the subtraction. 3 minus minus 24 is plus 27, 3 minus minus is 3 plus, and then minus 2 subtract 10, well, that's minus 12. So 27 minus 12. This thing here, hopefully you know what that means. This modulus sign here, that means the magnitude. So the magnitude of the vector, we do that using Pythagoras. So that's minus 12 squared, sorry, the square root of minus 12 squared plus 5 squared. Minus 12 squared is 144, 5 squared is 25, add those two things together, 169, and if we square root that, that gives us exactly 13. In this next question, sometimes it helps a little bit to do some kind of sketch. So point A is up here, that's 7, 5. Point B would be over to the left and down a bit. And we want the vector that's going to get us from A all the way to B. So you can see if you put the points in the right position that we need to go left and down. Let's look at the x-coordinates first. From 7 to 2, well, that's 5 left, so that means our top number is minus 5. And then from 5 to 2, that's 3 down, so then our bottom number is minus 3. Another magnitude question. So again, a bit of Pythagoras. So it's the square root of 9 squared plus negative 3 squared. 9 squared is 81. 3 squared is 9, so that gives us the square root of 90. This is probably a non-calculator question given it wants it in its simplest third form. So the biggest square number that goes into 90 I think is 9, so let's write the square root of 9 times the square root of 10, and the square root of 9 is 3, so that is 3 root 10. Okay, so here we're going to multiply this vector by 2, so 2 times 2, 3 would give us 4, 6. And then minus 3, 5. So now we've got 4 minus 3, that's 7. And 6 minus 5 is 1. So our answer is just 7, 1. Next question, f is the point 5, 7. I think again, I'm just going to do a little sketch of this. Let's say 5, 7 is there. The vector that maps f onto g is minus 1, 3. So that means that we're going to go 1 left and 3 up. So 1 left, 3 up is over here somewhere. Okay, 1 left would be 4 on the x coordinate, so 5 take away 1 is 4. And then add 3 onto the y coordinates, 4, 10. Yeah, that would be a translation of 1 left, 3 up. So g is 4, 10. You might have figured out that actually all we could have done is just basically added this vector to those coordinates. So 5 take away 1 is 4, 7 add 3 is 10. Sometimes those diagrams help us just a little bit to visualize it though. Nice and easy here, just be careful with your negatives. 1 minus minus 5, that's 1 plus 5, so 6. 2 minus 3 is minus 1. Okay, again, I'm going to do a little sketch for this one. Minus 3, 6, so that's minus 3 on the x-axis, 6 on the y-axis, so over to the left and up. Q is 0, 2, so that's to the right and lower. So to get from P to Q, well, let's look at the x coordinates. I need to go 3 right from minus 3 to 0, so 3 right. And I need to go 4 down from 6 to 2, so that's minus 4, 3 minus 4. Again, a nice easy one here. 4 times by 6, 2, well, we multiply them individually, so 4 times 6 is 24. 4 times minus 2, minus 8. And then, again, a nice easy magnitude one. Square root of 2 squared plus 6 squared. Square root of 2 is, 2 squared is 4, 6 squared is 36. Add those things together and we get the square root of 40. And then simplify that. I think the biggest square number is 4 that goes into that. So 40 is 4 times 10. Square root of 4 is 2. So 2 root 10. This question wants us to find the magnitude of the vector a minus b. To do that, first of all, let's find the vector a minus b. So a is 4 minus 10. Subtract b, which is minus 4, 2. So we've got 4 minus minus 4, which is 4 plus 4, so 8. And minus 10 subtract 2 is minus 12. Now let's go ahead and find the magnitude of that. Okay, that's by doing a bit of Pythagoras. So we've got the square root of 8 squared plus minus 12 squared. 8 squared is 64. Minus 12 squared, 144. Let's add those two things up. What's that? 208. So we've got the square root of 208. Now, I know this is divisible by 4. I'm not sure if it's divisible by 16. I think it might be. But let's do it one step at a time just to check. So I'm going to do root 4 times by, now that divided by 4 is going to be 52. Okay, square root of 4 is 2, so I've got 2 root 52. And at this point here, we need to check this thing again. So that 52, is that divisible by 4? Yeah, because 4 goes into 40, and 12 is divisible by 4 as well. 40 plus 12 is 52. So 52 is 4 times 13. 4 times 10 is 40, 4 times 3, 12, yeah. So root 4 is 2. So we've got 2 times root 13, or 4 root 13. Of course, if you spotted straight away that 208 is equal to 16 times 13, you could have gone straight to that by writing root 16 times root 13, and root 16 is 4. Okay, it's not always that easy to spot, so it's okay to do it in a few steps as well, but you do need to get it in its simplest form. Okay, here let's find v minus y, so that is equal to v minus 1, 3, minus y, which is 2, 5. So we've got minus 1 subtract 2, that's minus 3, and 3 subtract 5, minus 2, nice and easy. Next is 2v, so that's 2 times minus 1, 3, 2 times minus 1, minus 2, 2 3's 6, so minus 2, 6. Okay, point A has coordinates 6, 4, point B has coordinates 2, 7. So 6, 4, well that's kind of a crossover to the right and up a bit. Okay, point B has coordinates 2, 7, x coordinates are 2, so it's over to the left, and it's above, so here. Okay, so to get from A to B, well, we need to go from 6 to 2 in terms of the x coordinates, so what's that, 4 left, so minus 4, and we want to get from 4 to 7, so that's 3 up. Of course, you can do this by subtraction as well, but doing that diagram helps you to kind of visualize the problem. So we've seen questions like this before, but just notice the different notation we sometimes use. So we've got fg equals 8, 3. So this just means the vector going from f to g. First, we just want to do 3 of that vector, so 3 of 8 minus 3. So 3 times 8, that's 24, and 3 times minus 3 is minus 9. And then it's asking us to add these two vectors, so 8 minus 3, add gh, which is minus 12, 35. So 8 add minus 12 is minus 4. It's the same as 8 subtract 12. And minus 3 add 35 is 32. Okay, now we're asked to find the coordinates of the point G. Again, I'm going to do a little sketch to help me here. Let's say this is the point F, 1 minus 4. And the vector that goes from F to G is 8 minus 3. So that means from F we're going to go 8 right, 3 down. Okay, so 8 right from F, well that's 9. And 3 down, minus 7. Okay, it's as simple as that. We could have done it again by just adding on that vector, you'll notice as well. 1 add 8, 9, minus 4 add minus 3 is minus 7. Okay, now it wants the magnitude of the vector GH, so the vector GH was minus 12, 35. So a bit of Pythagoras, minus 12 squared plus 35 squared. Judging by the numbers, I'm guessing this is a calculator paper. This one we can do no problem, 144. I don't think we're expected to know 35 squared, although we could figure it out if we needed to, doing a bit of long multiplication. So 1,225. Add those two things up and we get 1,369. Does that simplify at all? It does. It's a square number, 37. Okay, next question. Doesn't look too bad, so we're going to do 3q, 3 times minus 4, 5. 3 times minus 4 is minus 12, 3 times 5, 15. Next, p minus q, so p is 8 minus 5. Subtract q, minus 4, 5. 8 minus minus 4 is 12. Minus 5 subtract 5, minus 10. Simple as that. And then we're going to use the answer that we just got and find the magnitude of it. So again, using Pythagoras, so it's square root of 12 squared plus minus 10 squared So that's 144. Add 100. So that is the square root of 244. So again, I can see that this is divisible by 4. I don't know if it's divisible by anything bigger, so we'll do at least that 4 first. So root 4 times by, so this thing divided by 4, well 200 divided by 4 is 50, and then 44 divided by 4 is 11, so 50 add 11, what's that, 61. So 2 root 61, now 61, I don't think that's divisible by anything useful, certainly not a square number, so I think that's as simple as we can make it. Let's write 2 root 61. Okay, we're going to find p minus q. P is 2, 8, minus 1, 4. 2 minus 1 is 3. 8 minus 4 is 4, so that first one is just 3, 4, nice and easy. Next, 6p, so 6 times 2, 8. 6 2s are 12, 6 8s, 48, so 12, 48. And then the magnitude of p minus q, well p minus q we found up here is 3, 4. A bit of Pythagoras, square root of 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16. Add those two things up and we get square root of 25, and the square root of 25 is just 5. Let's write it on the answer line. Okay, so now we're going to add up these two vectors. 6 add 8 is 14. Minus 5 add minus 1 is minus 6. Next we're going to multiply this one by 3. 3 times minus 4 minus 12. 3 7s, 21. I almost wrote 27 there, 21, sorry. There we go. So now we're given the vectors p and q, so p is 3 minus 1, and we're going to add together 1 minus 2. 3 plus 1 is 4. Minus 1 add minus 2, minus 3, so 4 minus 3. A is the point 27, it's translated to the point B by the vector P plus Q, find the coordinates of B. So it's referring to this vector up here. So here's our point A, 2, 7, and it's translated by this vector, so it's going to go 4 to the right and 3 down. So 1, 2, 3, 4 to the right, 1, 2, 3 down. Okay. Well, 4 to the right of 2 is 6, just by adding that on. 2 add 4 is 6. And 3 down from 7 is 4. Yeah, 7 add minus 3 is 4. So point B must be 6, 4. Okay, let's do the multiplication in this one first. So I'm going to do 12 minus 5. I'm going to leave the minus sign here. I'm going to do 5 times by each of them. Okay, so 5 times 4 is 20. 5 times minus 1 is minus 5. And then I've got 12 take away 20, that's minus 8. And minus 5 minus minus 5, well that's the same as minus 5 plus 5, so that's 0. So minus 8, 0. The magnitude, again Pythagoras, so square root of 3 squared plus minus 4 squared. 3 squared is 9, minus 4 squared, 16. So that's the square root of 25, which is equal to 5. Another magnitude question. So the square root of minus 6 squared plus 8 squared. Minus 6 squared is 36. 8 squared is 64. Add those two things up and we get square root of 100, and the square root of 100 is 10. Okay, and now we're going to find a minus 3b, so a is minus 4 minus 3, minus 3 times 2 minus 1. Again, I'm going to leave that minus sign and I'm going to do 3 times by 2, which is 6. 3 times minus 1 is minus 3. Then I'm going to subtract. 4 take away 6 is minus 2. Minus 3 minus minus 3, well that's the same as minus 3 plus 3, so that's 0. So minus 2, 0. And then the magnitude of this vector is the square root of minus 4 squared plus minus 3 squared. Minus 4 squared is 16, minus 3 squared is 9. Add them together. I feel like we've come across these numbers a fair few times recently. Square root of 25 is 5. Similar questions to ones we faced, but again with this slightly different notation. So 3 times AB, so that's 3 times 7 minus 3. 3 sevens are 21. 3 times minus 3 is minus 9. And then we want the magnitude of AB, careful not of this new one, but of the original one. So square root of 7 squared plus negative 3 squared. 7 squared, 49. Minus 3 squared is 9. So that's the square root of 58. I don't know if that simplifies, but it doesn't ask us for it in a simplified form anyway. And I don't think it does. 4 is not a factor of it. I can't think of anything useful that would go into it. Okay, this one's slightly different. The magnitude of this vector is 29. Okay, but we're not told the component. So slightly different magnitude question. We're going to start the same way. We're going to write the square root of 20 squared plus k squared. And that must be equal to 29 because we're told it is. Now to solve this equation, we need to be able to get rid of this big square root. To do that, we're going to square both sides. When I square both sides, I'm left with 20 squared plus k squared. And we'll square this right hand side, so 29 squared. I assume this is a calculator one, but you could figure it out if you really needed to. So 29 squared gives me 841. Let's work out 20 squared as well while we're at it. So 20 squared is 400. And then we want to solve this equation. So to solve this, we're going to subtract 400 from both sides. So 841 take away 400 is 441. And then we're going to square root that. Now, actually it doesn't tell us that k has to be a positive number, so I guess that k could be 21, or it could be minus 21. There's no reason why it couldn't be a negative answer. The square root of 441 is 21, but it could be minus 21 as well. I'd be interested to see what the mark scheme said for this one, because I think there's 2 answers there, but there's not really a hint in the question that there's 2 answers, so a bit of an unusual one. Maybe let me know in the comments if you come across the mark scheme, what it says. That would be useful for us to know. Part B here, Ahmed finds the magnitude of vector 2 minus 3. From this list, put a ring around the correct calculation. Okay, so this one here is not okay. If you did this one, BIDMAS tells you to do 3 squared first and then put the negative in. So you'd end up subtracting 9. So this would give you 4 take away 9. Okay, doesn't work. This one, no, you definitely need the square root. This one, it's got the square root, but again it's subtracting, so that's not right. This one looks okay, but we need the square root there, so it's this one here. Square root of 2 squared plus, in brackets, negative 3 squared. That's the one we want. Okay, so here we want to find 2p first, so 2 times 4, 5. And then we're going to add it to q, which is minus 2, 7. 2 times 4, 5 gives us 8, 10. And then 8 add minus 2, well that's 6. And 10 add 7, 17. Okay, next one, well this means the magnitude of p. So Pythagoras, so square root of 4 squared plus 5 squared. 4 squared is 16. 5 squared is 25. So that's the square root of 41. Doesn't tell us to simplify it, and it doesn't simplify. A is the 0.41 and AB is minus 3,1. Okay, so let's put point A over here, 4,1. So to get from A to B, we're going to go 3 left and 1 up. So 1, 2, 3 left and 1 up. So B is over here somewhere. If we're going 3 left from A, that's 4 take away 3, which is 1. And 1 up from 1 is 2. Again, we could have just added on this vector onto this A. 4 add minus 3 is 1. 1 add 1 is 2. Okay, ABC is a triangle. B is the point 1 minus 10. A is the point 4, 14. And C to A is minus 11, 8. Okay, again, I think a sketch might be a little bit helpful here with the points roughly in the right position. So if B is 1 minus 10, let's put that one down here somewhere. A is the point 4, 14, so that is to the right and up. And then it says C to A is minus 11, 8. Now it's giving me C to A, but actually I think what's more helpful is to know what A to C is. So if C to A is minus 11, 8, then A to C is going backwards along this one. So to do that, we do the negative of this vector. So that's going to be 11 minus 8. Okay, that's a really important thing to be able to do. So now all I can do with that is I can add that onto A to work out where C is. So C is going to be 11 to the right and 8 down from A. Okay, so 11 to the right of 4 is 15. 4 add 11 is 15. And 8 down from 14 is 6. Yeah, 14 add minus 8 is 6. So the point C is 15, 6. Now we're asked to find BA. Okay, again, let's use my diagram. So from B, looking at the x coordinates, well, I'm going from 1 to 4, so that's 3 to the right. And then from minus 10 all the way to 14 is 24. We could also do that by doing this. Yeah, by doing BA equals A subtract B, that's 4, 14, subtract 1 minus 10. 4 take away 1 is 3, 14 minus 10 is 24. Here it wants the magnitude of CA, so that's the square root of minus 11 squared plus 8 squared. Minus 11 squared is 121, 8 squared is 64. Add those up, 185. Is that something that simplifies? Not sure. Doesn't tell us to simplify it, so I guess we leave it as that anyway. Okay, here we're going to do B minus A first of all, so 2 minus 5. Subtract minus 3, 8. And we've got 2 minus 3, that's 2 plus 3, so 5. And minus 5 subtract 8, that's minus 13. So 5 minus 13 here. This one is 2A plus B, so 2A first of all is 2 brackets minus 3, 8 plus 2 minus 5. 2 times minus 3, 8 is minus 6, 16, plus 2 minus 5. And then minus 6 add 2 is minus 4. And 6 add negative 5 is 16 take away 5, so 11. Then the magnitude of B, so Pythagoras, that's square root of 2 squared plus negative 5 squared. 2 squared is 4, negative 5 squared is 25, so the square root of 29. and I don't think that simplifies. Slightly unusual question compared to what we're used to. We're given a plus k times b, so let's write that out first. So we've got a, which is minus 3a, plus k times b, and b was 2 minus 5. And we're told that that is equal to 13m. Okay, so first of all, I'll tell you what, let's just look at the top row. So if we look at the top row, we've got minus 3 plus 2k is equal to 13. Okay, that's just looking at those numbers along the top, and from that you can already solve it to work out what k is equal to. Let's add 3 to both sides and we get 2k is equal to 16. So k is equal to 8, so we've got that already. Now we're going to use the fact that k equals 8 to work with the bottom row. So the bottom row says 8 add k times minus 5 is equal to m. Okay, so 8 add k times minus 5 or 8 minus 5k. We just worked out what k is, it's 8. Okay, so then we've got 8 subtract 40 equals m, and 8 subtract 40 is minus 32. This question is a bit tricky, and especially in the way it's presented. So if you look carefully here, we've got the magnitude symbols either side of this vector. Okay, so what it wants us to do is find the magnitude of this, or find m when the magnitude of this is equal to 205 over 2. I think it makes it even more difficult the fact that they've written 205 over 2 here, rather than even just writing that as 102.5. So let's straight away write that. Okay, so for the magnitude of this vector, I'm going to do Pythagoras. And I want to do the square root of this thing squared, so in brackets 9m squared plus brackets 40m squared. And all of that thing square rooted must be equal to 102.5. Let's work out what these things are underneath the square root. So 9m all squared is 81m squared. 40m squared is 1600m squared. And the square root of all of that is 120.5. We can add those things up now. So that's 1681m squared, all square rooted, is 102.5. Okay, so what we're going to do next is we're going to square both sides. Okay, so if we square both sides, on the left hand side we're going to get 1681m squared equals, and let's square 102.5. I get this pretty horrible number, 10,506.25. Now let's divide by 1,861 and hope we get a little bit of a nicer number here. So that divided by 1,681. Oh yeah, sure enough, we get quite a nice 6.25. And then we're going to square root 6.25. And remember, it can be positive or negative, so it's plus or minus the square root of 6.25, which is 2.5, or negative 2.5.